And welcome back to Math Concepts. In this video we will be discussing how to use truth tables to determine whether two statements are equivalent. It's kind of a funny thing about language in that sometimes there are two different ways to say the same thing. And that's what we mean when we're talking about statements being equivalent. Now, the way that we can tell whether statements are equivalent is by looking at truth tables. So we're going to look at examples of how to do that. We're going to also look at something called DeMorgan's laws, which is about two different ways to say the same thing. The good news is having two different ways to say the same thing gives you some flexibility, and you can choose whichever way is best. So let's switch over to the document camera and look at equivalent statements. So the key idea for this video is using truth tables to determine whether two statements are equivalent. And we'll just get into an example here. We're going to determine whether these two statements are equivalent. Okay, so step one. Write the truth table. For each statement. Okay, so not P and Q. Let's go with the truth table for that first. So in this problem we've got two statements. So our truth table will need 4 rows. Once again, we start inside the parentheses. Here I can just copy the truth values of P and Q to get started. Now here's my first operation. It's an AND operation. So true, false, false, false. Okay, so once again we remember that the AND operation is only true when both of the inputs are true. And I'll write down the order I'm filling this stuff out in. I filled out that column, then this column, then using both of those I did this. And now we're going to do the negation of column 3. And that's going to be my last step. So column 3 right here is true, false, false, false. So the negation would have the opposite truth values. All right, now for the next statement, we're going to have this truth table. Okay, so we got statements P and Q, and we're going to do not P or not Q. Okay, so once again, I need 4 rows. That'll cover all possible truth combinations. All right, now here I have not P, not Q. So for my first step, I'm going to base my answers on the values in this column. But they're going to be the opposite values because we're dealing with not P. And here we're going to do not Q. So it'll have the opposite values that we see in the column for Q. And now we're going to apply the OR operator. This is my last step for this one. Going to apply the OR operator to these two inputs. Now you'll remember that the OR operator gives us a true when at least one of the inputs is true. At least one. Now here we don't have any, so that's going to be a false. But the rest of them are going to be true, because the rest of them have at least one true. Okay? So, this is the kind of final answer for not Q or not P. And this column right here is the final answer for not P or Q. Okay, notice the values. False, true, true, true. Okay, they have the exact same truth values. So, not P and Q is equivalent to not P or not Q. Okay, I wrote that down there, you couldn't see it. Okay. So the basic idea is write out the truth tables for the statements. If you have the same truth table, then you have equivalent statements. Okay, the same truth table means you have equivalent statements. Now, the equivalence that we just established is a special case of something called DeMorgan's law. Okay? So, actually, I guess it's DeMorgan's laws because there's two of them. So DeMorgan's laws says the one thing we just established, the negation of P and Q is equivalent. Okay, that's the shorthand for equivalent, an equal sign, but it's got 3 lines. Not P and Q is equivalent to not P or not Q. And there's another one, there's another version. And that's this right here. The negation of P or Q is equivalent to not P and not Q. So what I want to do is show you an example or two of using DeMorgan's law when we have statements written out in words. Okay, so let's start out with this one right here. It is not true that I am going to the dance or going to the game. All right, so here's the form that we have. Okay, so it's the negation of an or statement. So it's not true. What's not true? Going to the dance or going to the game. Okay. Now, DeMorgan's law says this is equivalent to not P and not Q. So our rewrite looks like this. I am not going to the game and not going to the dance. Okay, so that is a rewrite of a statement using DeMorgan's law. And remember, the truth tables that we looked at earlier in the video established that these two things are logically the same, logically equivalent. And we know that because they have the same truth tables.